Welcome to the beginning of the videos for the Math 263 topics. This will be Calculus 1 with Analytic Geometry Part 1. I am using a different textbook than what you typically use in your course because I wanted to do this through my labs instead of through WebAssign, just because it's easier for me to create the worksheets this way. So same topics, same objectives, different chapter and section numbers and problem numbers and things like that. All right, let's go ahead and get started here with 1.1, Objective 1, where we're going to answer conceptual questions involving functions. This is just Chapter 1 is going to be a review of functions from pre-calculus before we jump into the calculus topic. So a function is a rule that assigns each value of the independent variable in the domain a unique value of the dependent variable in the range. In question 2, does the independent variable of a function belong to the domain or range? Does the dependent variable belong to the domain or range? The independent variable of the function belongs to the domain. The dependent variable of the function belongs to the range. Let's decide now whether graphs A and B over here, A is in black, B is in blue, represent functions. So which one is a function? We're going to use the vertical line test to test here. Function B, graph B is a function, but A is not a function. It's a relation, but not a function. So only B is a function since A does not pass the vertical line test. Which statement about a function is true? For part 1, for each value of x in the domain, there corresponds one unique value of y in the range. Part 2, for each value of y in the range, there corresponds one unique value of x in the domain. Explained. So it's number 1, little Roman numeral 1 is true. Statement 1 is true because the function f is a rule that assigns each value x in a set of a unique value donated f of x. The domain is the set of all values of x for which the function is defined. The range is the set of all values of all values of f of x produced as x varies over the entire domain. So there's your fill in the blanks there for that one. Explain how to find the domain of the composition f of g if you know the domain and range of f and g. So first identify the x values in the domain of g whose corresponding range values are in the domain of f. That's how we're going to find the domain of f of g. And answer the following questions about odd and even functions. So if f of 0 is defined and f is an even function, is it necessarily true that f of 0 equals 0? No, not necessarily, because if f is an even function, there are many functions where f of 0 is not 0. For example, the function f of x equals x squared plus 5, and f of x equals cosine x minus 2. So that's D. Can have any y-intercept we want to. It just needs to be a reflection over the y-axis. Now, if f of 0 is defined and f is an odd function, is it necessarily true that f of 0 equals 0? Yes, it is, since we have to have origin symmetry, so it has to be at the origin because f of negative x has to equal negative f of x. If f is an odd function, and because the opposite of 0 is equal to 0, then f of -0 equals f of 0 equals negative f of 0, and that has to equal 0. So the only number which is 0 is the only number which is its own additive inverse. So f of 0 has to be 0. I didn't say all the words exactly the same way there, but it's option A. There, and we've got one more question here, number 7. Decide whether the graphs A, B, or both represent functions. So A is a zoom in here. A is not a function because it has this nice little loop in it right here and doesn't pass the vertical line test. You have to probably zoom in like I did to see that. But B is a function here. It just goes up and turns a little bit and keeps rising. So B is a function, A is not, because they had A do a little loop-de-loop here, and it won't pass the vertical line test. All right, that's it for this video, and we'll come back next time and talk about 1.1 Objective 2 from this textbook. So we'll see you for the next video.